Into a bit of a servo and Android mini conf today. And basically it's how to turn a droid into a toaster, though that's kind of like a bit of a smart alecky term, so I don't want to have anything to do with toasters, especially all that burning stuff and electricity. So what I'm going to be talking about is an Android app that actually turns an Android device into an appliance. So it basically means that unlike your ordinary app, this app or apps is intended to be the sole focus of the device. It's basically the sole reason for using the device. So what do I mean by appliances? Well, that's what the dictionary says, and I think it's about right. Things like this I'd consider an appliance. Of course, the conventional microwave, definitely an appliance. But in this talk, I'm actually going to talk about something called interactive digital signage appliances, which I mentioned in my previous talk if any of you were here earlier this morning. It's a bit of a mouthful, but basically it means things like this, like kiosks that you come up to in shops, shopping centres, and that you interact with them in some way. Although sometimes doesn't have to be direct interaction, it might be just walking up to it and a sensor triggers something to play, like a video to play, or give you some kind of message. Now, if you want to have an Android device turned into an appliance, you need to customize it because they're basically consumer devices out of the box. They're meant for you to use as a phone, as a tablet. Now, customizing an Android device basically means you've got 3 levels at which you can work at. User level is number 1. Basically, I mean, it's the normal kind of things that you can do as a user of a phone or as an app developer. It's the kind of means that are available to you if you're putting an app up somewhere like the Google Play Store. Next, there's the platform. This you can think of kind of as a quasi-root level access. Because Android's security model actually involves protecting sensitive APIs from apps that aren't sanctioned by the hardware vendor, yes, it's open but it's controlled, it means that basically only apps that are signed with the same certificate that the Android operating system that on your device was built with get to have access to these APIs. So in Android, basically, all apps are created equal, as it were, and as an animal farm, some are more equal than others, and the ones that are more equal than others are the ones that the vendor, Samsung, HTC, whoever, have signed with the certificate that they put onto the system image when they built the operating system for that device, and they get to have access to all the special privileged bits of the API that normal apps aren't allowed to touch. Which is, for security and consumers, usually a good thing, but you need to be able to work with that if you're going to customize it. Now, the main thing here to note is that, like with most other phone devices from other manufacturers like Apple or the Windows phones, and not like your average tablet or desktop, the end user does not, or it's not intended to have any kind of admin or root level access. And this is the kind of thing BDAL was talking about at the keynote this morning if you were there. These devices are not intended for you to have complete control over. Unfortunately, the state of affairs is it's probably going to get worse, I'm afraid, because these could. I know BDAL wants everyone to use desktops or laptops running general purpose operating systems, but to my mind, the writing's clear on the wall. The future for most people is using these devices, and unfortunately, at least on the Windows iOS side of things, they are very locked down. They make Windows look very open and inviting in comparison. Now, the third level is the operating system, which I guess that's the bit that we're all familiar with, tinkering with Linux. And in fact, at this level, what I'm talking about is rebuilding from source code the actual operating system. So any Gentoo users here, or the like? Excellent. That's the kind of thing I'm talking about, rebuilding everything from source.
Linux from scratch.
Yeah, same kind of thing, yeah, but yeah, I'm surprised there weren't more hands, but I guess, yeah, not many people do it these days. So what can you do at the user level side of things? Well, you can use the home intent. Now, for those of you who aren't familiar with Android app development, basically an intent is like a inter-process communication mechanism. It's a way for apps or components on the operating system to talk to each other, similar to dbus, if people are familiar with dbus on your standard on your standard Linux distros. So Android is actually made up of just a whole bunch of interoperating, cooperating components, as it were, as much as it is different apps. And they talk to each other by broadcasting or sending direct messages to each other. That's what these intents are. So what people think of as the home screen or the desktop when you use your Android phone or tablet is really nothing more than an app which is registered with the operating system to receive a well-known intent called the home intent. So when you see the home desktop there, what you're actually seeing is just the app that's registered itself as responding to that intent. And the operating system, when it boots up, it says, I want to show the user's home, and so the app that's registered for that gets displayed. Now, this is all you have to do, like it is XML, but this is all you have to do to register your app to respond to that intent, just that one line saying, and that's that bit up there, Android intent.category.home, that's kind of like the well-known name that Android has defined as the action that you want to see the home screen. So when you use, you don't have to use, you can, apart from just using the home intent, you can use other intents that are public in that they're somehow documented in the Android SDK or the documentation. For example, you've got the Wi-Fi config app. So I guess a lot of you have seen that today if you've been trying to get your Android phones or tablets onto the Wi-Fi network here. But the thing is, there's nothing special, there's something special about it, but really it's just another app or an activity that's part of one of the system apps. So in order to display that, when you go into your settings, all that happens is the settings activity sends an intent saying, hey, when you click Wi-Fi, I want to show the Wi-Fi configuration activity. And sending intents is just as easy as registering for them. Basically, that's the code that you need. Now, I know people think Java's verbose and horrible and everything, but it's not that bad. And okay, I admit, for Java, that is Zen-like minimalism there. Like, you can't get much simpler than that, but that's all it takes. So that's all you need if you want in your app to say, display the home screen, or the app that's registered for the home screen. That's all you need to do. Oh, sorry, show the Wi-Fi configuration. Sorry, that's all you need to do. So there you go. Like in your app, you write that bit of code in response to someone pressing a button or something. Hey presto, up pops the Wi-Fi config. So maybe you've detected your app needs Wi-Fi or internet access. You want to jump the user to that, you just have a little bit of code saying, hey, show this, pops up. Now, that's all fine for a normal app, but if you're building an appliance, usually you don't want people to have access to the operating system itself. You don't want them to know they're even using Android. They're using some kind of appliance. So for instance, they've got like a DVD player or a Blu-ray player they want to connect to the Wi-Fi network. So you just want to show them the Wi-Fi configuration, get them on, and then go back to your own custom user interface. So what's the problem here? You've got this stuff here. What's that got to do with my Blu-ray player? And why is there a back button to what? Like, you know, that's not what the user's going to get confused. So that's not what we want. And what we want is just basically the Wi-Fi configuration activity and nothing. So just basically the inner bit and nothing else. Now, the problem is, how do we do that? Because the Wi-Fi activity, because of the security model I was talking about, that's a privileged API. Oh, sorry, it potentially uses privileged APIs. In this case, you could recreate the whole Wi-Fi configuration activity yourself, but that's a huge amount of code. You're going to have to cover all the corner cases that all the Google engineers had to when they wrote that, so there's no point reinventing the wheel. That's the whole point of having intents in Android, is that you use these standard modules or components rather than having to reinvent the wheel yourself, which is a bit familiar from the desktop Linux distro side of things, but in Android you're not supposed to do that. Now, I don't know if anyone's paid much attention when they configured their Android device for the first time. You had like a kind of welcome wizard thing that stepped you through, hey, please sign up to your Google account, please give us permission to track you, But one of the things is, if you're not already on a Wi-Fi network, or if you're using a tablet, like your phone might be already on a 3G network, but if you're using a tablet, you won't be on a Wi-Fi network. So it pops up the Wi-Fi configuration activity for you. And what I noticed was that, hey, it doesn't have any of those extra controls that I get when I use the public activity. I thought, how did the Google engineers do it? So, because I needed to do this, I should say, I need to do it for my application. Now, I discovered Google engineers must be somewhat big Kirk fans, like myself actually, because I always think, what would Kirk do in a situation where I need to do something, but clearly it can't really be done? And so, yeah, this is only a reference to people who've seen the movie, but what you do is you change the rules of the game, clearly. Like, if something's impossible, you just change the game so it's not impossible any longer. So what you find, if you go into the source code, because luckily this is the big thing, like, don't let people tell you Android is somehow proprietary or Google controls it. Well, they do control it, but it's all open source. Just because they dump it off to us every 6 months or so doesn't mean all the code is not open source. It's not sitting there on their Git repositories ready and waiting for us to grab it and read it. And when you do read it, if you read the bit which covers the Wi-Fi configuration, what you find is there's these strange, undocumented, completely undocumented in the API documentation, special case parameters with funny names like only access points, extra prefs, show button bar, enable next on connect. And you think, that's a bit strange. Like, why are they just in a general purpose Wi-Fi activity? Why are they there? I think you know the answer. It's because if you pass those extra parameters when you fire off that intent I showed you before, you get this. No more like wrapping Chrome, no back button, the back, you do get a back button if you ask for it. This is a screenshot I took. That was one of the extra parameters you pass in, is you say, I want the back button. You can actually even say what text you want. I had I've got a nice finish here because that's from the production app. Like previously I had, hey, yeah, go for it. Because you can put anything you want there. So, that's basically the limit of what you can do if you're sticking to the user level customizations. You can basically use the intents, documented or otherwise, but that's it. Any more customization you want to do, you need to go down one level to the platform. Now, with platform level customization, basically you can do a number of things. The first thing is you can call privileged APIs, as I mentioned previously. These are the things that, if your app is signed with the magic certificate that the operating system has embedded in it when it was built, you get to call these special APIs. Again, some of them are documented, like out in the open, even though no ordinary developer can call them. Google still documents a lot of them. Others are hidden, as in they're a little, in the documentation in the open source project, they have documentation, and then there's a special tag to tell the program that generates the SDK documentation, don't display this on a public website. There's actually a little @hidden flag to say, no, like, okay, if someone bothers to read the source code, sure, but this is not to be made public in an easy fashion, I guess. It's a bit strange hiding. This is the thing, people talk about hidden APIs on something like iOS. Well, sure, they're hidden, like no one knows about them. You have to do all kinds of tricks to find out about them. With an open source operating system, they're only hidden until you actually bother to download the source code and spend the time to read it. Now, I think you might be wondering, what do I mean by silent? Well, I think Paul mentioned previously, like when they do an update, like someone had a question about security, it has to be, an update to an app has to be signed with the same certificate as the original app. But what also happens is whether or not, whichever mechanism you use to do the update, you get a little prompt asking you, hey, this app wants to install itself, here's the permissions it wants, are you okay with this? It's a little user interface thing. Because the thing is, there's actually an intent to trigger that. I assume that's how you guys in the Serval project do it. There's just an intent that you fire off saying, hey, I've got a new version of this app. Please ask the user if they will allow me to install it. Now, this is okay if it's a regular kind of app. For something like digital signage, you do not want to have a big user interface thing stuck up in front of everyone saying, hey, this app needs to be updated, do you grant permission? That doesn't look so good. So what there is a hidden platform API, which if your app is signed with the right certificate, you get to do silent updates or over-the-air updates, which means the app just silently installs the new APK, the user is none the wiser. No notifications, no UI pop-ups, nothing, it's just installed. Although it still does a certificate check, strangely enough, so there is still that security mechanism, but you don't have to bother the user with it, just install whatever you want. Now, when I said there were 3 levels of customization, I kind of lied. There's actually 4. So OS level, you can really break it down into 2 different parts, Android framework and the kernel. The Android framework customization, well, that means basically building the operating system from scratch. It's what our friends at, if you're a Gentoo user, you do it. Otherwise, friends at Ubuntu, Fedora, whoever is the distro maker, that's the kind of thing they do for you. And that's what you can do yourself, because you can just download all the Android source code and do it for yourself. But check it out, I kid you not, hundreds, I think 240, 250 Git repos. They wrote a special Python tool to manage Git to be able to work with that many repositories for your just everyday development, because it's horrendous otherwise. Lots of disk space, I mean lots.
2-3 gig just for the source?
Yeah, but that's just for the source, and then you actually kick off the build.
Probably about 10 gig to build.
Yeah, I think 10 is, or 15 is what they say is the minimum. They recommend 50 if you want to have like a cache, so when you're rebuilding often, it doesn't take as long.
Is it because it's in Java?
No, it's because it's a whole operating system. How many people have built Ubuntu or Fedora from scratch? No, I haven't either, but I'm pretty sure those guys have about the same amount of code. It's a whole operating system. It's not just the kernel. It's not just because it's Java. It's because there's a heap of stuff there. There's a lot, and it's a minimum. Like on my machine's a quad core i7, 1 generation back. It's about an hour with this thing getting really, really smoking. So it's something that not only is big, it takes a long time to do. And then once you've built it, all you have is an image, well, not even an ISO. Usually you have to package it up some more to make it into an ISO to install on an emulator or device. So then it's not a quick turnaround if you're making small changes. Cool, okay. Basically, it doesn't format very well. The things you can do, choose which apps you want you can ship. This is basically the same kind of thing you can do if you're making your own distro. You can customize the user interface, so for instance remove the system bar, choose the CPU platform. So for instance, I've been doing a lot of work recently, even though I'm a app developer, I've actually turned into a bit of a system developer just because we had to get stuff working on x86 boxes, and all it is a community effort. Intel is slowly starting to do stuff, but it's pretty much you're on your own. It works, but you've got to do a bit of work yourself. You control the platform. Importantly, you now get to put in which certificate the system checks when it lets apps do, when it lets apps access privileged APIs. And of course, at the kernel level, well, this is the kind of thing that if people have done kernel stuff before, you get to put in your own drivers. For instance, a vendor actually gave us a driver for a non-standard touchscreen that wasn't HID compliant, so that was the only way basically to get it working, because it was an out-of-tree driver. You had to compile your own kernel. So now, I hope I've got just enough time for a quick demo, but I'm happy to take questions while I quickly switch over and try and get the demo running. So in my demo, I'm just going to hopefully be able to show you some of the things I was talking about.
I was just curious when you mentioned that doing stuff at the Android level, you need to compile it and it was a whole lot of hassle. I just remember in my early playing around with Android, you could get like cooked ROMs where they weren't actually playing with the kernel or recompiling anything, but they could still mess with quite a lot of stuff without actually having to recompile it.
Yes, you can do it. There's no reason why you can't do it, because basically what they do is they take the binaries and they tweak them, or what you can do is you can compile, and I've done this to basically save time, is you can just compile one app, one system app or something that you're changing and stick that into a otherwise pre-built ROM and copy it onto the device. You can do that, but in the end, if you want a consistent build process like these things, what I need to do is build things that will go into production. I have to hand it over to other people to maintain. It's not a very good thing to do, to just be able to be tweaking binaries rather than do it correctly from source.
Yeah, for sure.
So, but you definitely can do a lot of stuff just by tweaking the binaries, putting your own stuff in. In fact, a lot of the stuff I did, I initially found it by doing that. The demo I've got here is, so this is an x86 build that I've made myself, and the thing I've tweaked here is this system bar is non-removable. Anyone who's got in Android 4 upwards, ice cream sandwich, like that's always there because a lot of devices have no physical keyboards. Again, that's not what I want people to see if they go into Myers or something and want to be interacting with the kiosk. So what I did was, this is basically sending an intent. This is just kind of like a debug command to send an intent called toggle system action bar with an extra bit of data, whether it's true or false. And if I just change that to false, hey presto, no more system bar. Again, do it true, back it comes. So basically, my app can just send that when it fires up, away goes the system bar, uses a nonweiser. It's basically a full screen application to them. One other thing I can quickly show you if I've got time. Oh no, sorry, I'm still in the, let me just get out, I'm still in KVM. Is what I was saying before with the home intent. So this is what you can do basically without modifying the platform. This is just basically any app can do this. You can register for the home intent. Oh, sorry, just 1 second. I have to I uninstalled the app just before coming on stage. So let me reinstall that again. Okay. So now if I press the home button, it asks me, see my app, like I showed you before, that little bit of XML is in this app. So now along with the default launcher, I've got my app registered. Now if I tick this box here, my app will now become the default home activity. So the launcher is no longer the default. So if I press home again, nothing happens because it's now going back to the home. It already registers the home intent. Even better, I have hijacked the back key, so even on devices which would have a back hardware button, I haven't hijacked it, I'm just handling the back event to do nothing. So once again, people can't get out. If you imagine, if you've got a mobile tablet that you want to give out to people, you basically do not want them to get out into the operating system. The people who use iPads and iTouches, they'll generally put them in big honking cases that block the physical middle bar, whatever they call it, the home button or whatever. With Android, if you've got a nice new tablet, it has no physical buttons, so as long as you hide the system bar, you don't have to worry about it. If you're giving them an older device with physical buttons, this basically stops them getting in and out, and it's not quite turning on and off, but I can show you, like, basically suspend if it turns off. It's essentially, rebooting the emulator is a bit tricky, but basically when they turn it on or reboot it, all that will happen is the default home is run by the system, which is again your app. So it's a completely lockdown system. So just because it's open, don't But that doesn't mean you don't get to lock down the system. That's I think what a lot of people get mixed up and get a bit upset because carriers might put a lot of their junk on there, or hardware vendors will change the UI of Android, and people say, oh, this is awful, this is not an open system. It's like they're mucking about with it. But that's the whole point. Open means you get to change whatever you want, but it also means HTC or Telstra get to do whatever they want. Like, open means open for everyone. It doesn't mean you're or they are more privileged and get to do stuff that you don't. Okay, thank you.
Time, thanks a good.